Welcome back to our Science Online Learning. This is your teacher Heidi. So our subject is Basic Science in Matheum 3 with the code of SC23102. So for today, we are going to study all about this topic. Okay, it's all about basic electronics. And the objectives of our lesson are the following. So first, you're going to identify the basic electronic components and their uses. Second, give examples of devices where these components can be found. Third, draw the electronic symbols of various components. Fourth, recognize the importance of these components in our daily life. Are you ready? Very good. For M3 Class 2, we have already started this one last month. And you have also done the activity that I told you to finish in our lesson. So you still have to listen carefully because there will still be other activities that will be given in this lesson. So when we say electronics, it is a branch of physics and technology involved with the design of circuits using electronic components and with the behavior and movement of electrons. Okay? So you can see in the picture here that there are a lot of our technologies or gadgets nowadays wherein the information of electronics is very important. Okay? So we can see some electronic components in these gadgets. Take for example, washing machine. Okay, this is your cell phone, your smartphone, your watches, smartwatches, headphones, okay, mobile phones, iPad or tablet, televisions, cameras, heating, air conditioners, and many more. Okay? So most of these are the things that we use, but did you ever ask why? What are these things made up of? How do they work? That's what we're going to take note on this lesson. But before that, let me remind you already what you're going to send later on. So for M3 Class 2, I know you have already done this one, but for M3 Class 1 and M3 Class 3, you're going to complete the table below about the electronic components. Use the information given in your science book or in this PowerPoint presentation given. So you're going to fill this up, copy as it is, and write this one in your science notebook. And then when you come back, I'm going to check your notebook. Now this will be graded. In the first column, we have the components. There are 5 components here. Second column will be the uses. The third column will be for the examples. And finally, the symbols. Now, every component here, you have to write carefully their or its use. Is that clear? And then you have to write some examples and finally the symbols. Now, this will be completed at the end of our period, or you can just do this one after our class today and then take it as a homework. Is that clear? All right. Okay. So let's move on to our lesson. Now, the first electronic component that I'm going to tell you is all about resistor. Okay. Now, resistor, from the word resist. What comes in your mind when you hear the word resist? Okay, so when you resist, you stop something, right? Or you control something. So here, a resistor controls the current flow and potential difference in a circuit. It also converts electrical energy into thermal energy or heat energy, measures temperature, and acts as a light-activated switch, depending on its specific properties and the design of the circuit. Is that clear? So you could see here an example of a resistor, a fixed resistor actually. And on this side, you can see the symbols used in the circuit diagram of a resistor. Is that clear? Very good. So when we say fixed resistor, it reduces the current in a circuit. Fixed resistors come in different forms such as cylinders or bars. Cylindrical resistors have color codes to specify the resistance value, the tolerance, and sometimes the reliability or failure rate. Alright, let's move on. We read the color of the bands from the first band, that is usually the closest, and then to the next bands. So every color here in the resistor must be studied carefully. Like for example, the blue color indicates what we call the multiplier. The red color here is the first significant value. The black color is the second significant value. And then finally, the last is what we call the tolerance. Now, when we say tolerance, the tolerance of a resistor is the maximum difference between its actual value and the required value. And it's generally expressed as a plus or minus percentage value. So, I will be showing you later on in the next slide. What do these colors represent? Okay, now here in your book, you can open as we go on with our lesson. Now in your book, you could see here different colors, right? Starting from the black, brown, red, orange, yellow, green, blue, violet, gray, white, gold, silver, and sometimes none. Now you could also see here some significant figures, which are usually single digits, and then the multiplier, and then the tolerance, which is the percentage. Okay, so every color here has a significant figure, and then the multiplier and tolerance. Now take for example this one. Now find the resistance of the fixed resistor that is shown below. Now this is an example of a resistor. Okay, so how many colors do you see? Very good, there are 4. We have the brown, black, the red, and the gold. So brown the first, black is the second, red is the third, and finally the gold. Okay, so you have to go back to the table and take note of the values of the given colors. So for example, brown is 1. So it should be here, right? And then black, let's move on to color black. It's 0, the second one. So it's already 1 and 0. And then the multiplier is red. Let us see red. So look here. It's 10 raised to the 2. And finally, the tolerance is gold. Let us see gold. Where are you? Very good. It's here. It's positive negative 5. So after putting all the values there, we are now ready to calculate. Okay, calculate the resistance value of this particular resistor. So 10 times 10 squared, okay, 10 squared is 100, right? So 10 times 100 is equal to 1,000. And then positive negative 5%. So 5% is when you multiply it with a number, so 5 over 100, you just change that one into 0.05, right? So 1,000 times 0.05 will give you 50 ohms. Is that clear? So the resistance of the resistor is 1,000 ohms with the tolerance of 5% or 50 ohms. So the resistance of resistor is between 950 minus 150. Now, why 950 to 150? Because there's a value positive, negative 5%. Okay? So let's first Let's first subtract. So 1000 minus 50 will give you 950. And then on the maximum side, this is the minimum. On the maximum side, it's 1000 plus 50 will give you 1050 maximum. Okay? So here the answer is 950 to 1050 ohms. So this resistor has a tolerance of 5%, which is 50% ohm, and has a resistance of about 950 to 1050 ohms. Is that clear? Very good. I hope you will do the next one carefully. Okay. Now do this one in 1 minute and let us check your answer. Please check your work. What did you get? Very good. It will give you 6,570 to 8,030 ohms. Who got it? Raise your hands. What about this one? 1 minute. What is the resistance of this resistor? Very good. It's 532,000 to 588,000 ohms. Okay? So I have to write it again for everyone to... So I repeat, it's 532,000 to 588,000 ohms. Who got it right? Very good. Okay, so that's how we compute the tolerance, the resistance of the resistors together with their significant figures. Did you understand? Okay, do you have any questions? Now you're going to do some of the activities here as we go on, later on. So aside from the fixed resistors, we also have variable resistor. Okay, now when we say variable, from the word varied, so it's changeable. Now the resistance of variable resistor can be adjusted to a desired value, and they are used in volume control knobs, light dimmer knobs. Okay, and the symbols are situated here. These are what we call variable resistors. Now we also have LDR, or what we call the light dependent resistors or photoresistors, is made of semiconductors. The light dependent resistors are used to detect light and change the operation of a circuit dependent on the intensity of light. When light falls on it, the resistance changes. The more intense the light, the higher the resistance of the resistor, causing less current flowing in the circuit. And the symbol is here. Okay. We also have thermistor, is a resistor that is sensitive to temperature. Its resistance value changes when the temperature changes. Thermistors can be divided into NTC and PTC. NTC is the negative temperature coefficient and PTC is the positive temperature coefficient. And the symbol of a thermistor is like this. Okay? So that's it. That's all about resistors. Now we also have here the second one, which is what we call a capacitor. So how do they look? Look at this. How do they look? Okay. Now a capacitor is sometimes called a condenser It stores energy in the form of an electric charge and releases the stored electrical charge whenever required. Capacitors are commonly found in electronic circuits. So capacitance is the electrical property of a capacitor, and it measures the ability of a capacitor to store an electrical charge, and the unit is farad. Now the symbol of capacitor is like this. Did you get it? So it stores energy. It's just like a water tank situated on top of our buildings or our houses, wherein it stores a lot of water, right? Okay. Now we also have the third one, which is a diode. This is read as diode, and is a two-terminal electronic component that only conducts current in one direction. So it's one direction conductor. So the common type of diodes in modern circuit design is semiconductor diodes, which come in different types. So the first type of diode is what we call a normal diode. We also have a light emitting diode, or the LED. It emits light when current flows through it. Okay. And take note of the symbol, by the way. Diodes, normal diodes, has a symbol of like this one on this side. And when we say light emitting diode, it has the symbol of like this. Okay. So don't forget that one. And light emitting diode could also be found in our electronic devices such as calculators and even our watches. Is that clear? Now we also have the fourth one here, which is a transistor. A transistor acts as a switch that turns a circuit on and off, controls the current, and amplifies electric signal. When you say amplify, I think it's magnify, or it makes bigger. Okay? Amplify. A transistor is formed by three-layer semiconductors, mostly made up of silicon. It has three terminals for connection, so it has three legs. Unlike the capacitor, the diode, they only have two legs. Transistors are composed of three legs, or three terminals for connection to an external circuit, corresponding to the three layers of semiconductors. The smallest one, which is the thinnest one, is the base, and the other two are collectors and emitters. The base controls the transistor, while the collector is the positive lead and the emitter is the negative lead. The two types of semiconductors, the p-type, made up of silicon and boron, and the n-type, made up of silicon and phosphorus, are joined by three layers of impurities to make a transistor with 2p-n junction. Okay, so you can see there the parts of a transistor. So how many legs does it have? It has 1, 2, and 3 legs. And the symbol of transistor is this one. Okay. All right, and let's move on to the last, the silicon chip. A silicon chip is an integrated circuit in which reduced size electronic components are packed. Okay, they are packed. Silicon is one of the most common substances used to develop chips. It is produced in cylindrical shape with a diameter of 5 cm, and it is then sliced into thin wafers on which electronic circuits of a processor or memory are printed before being cut into small square pieces of chips. So I think this one, silicon chip, it holds a lot of things in it. Okay, and compact, meaning a lot of things are present in this kind of electronic components. Okay, so silicon chips are mostly used for data storage. Okay, where can you find Where can you find data storage? Like in our memory storage, in our phones, okay, cards, ATM cards, and they are also used for data storage and operation used in automatic washing machines, okay, DVD players, artificial cardiac pacemakers, and microwave ovens. I think these are used in time-bounded appliances, okay? And then silicon chips are also used for data storage and processing, used in computers, digital cameras, and even barcode readers. So they process the information here, and then it will just give us the information right away. Okay, like when we use computers, digital cameras, and even barcode readers. Okay, so silicon chips are already the master, okay, here in all of the electronic components. Okay, so that's it. We have already finished the 5 electronic components. What's the first? Can you recall them? Very good. So did you understand our lesson, girls? All right, so activity time. I'd like you to open the PDF file, do the activity indicated about the resistors, print this worksheet, and send this when you come back to school. Good luck, girls! And finally, after our lesson today, click the link in MS Forms and answer the quiz. Your point will be recorded. That's all for today. See you in the next period. Take care.